Hello everyone. Today let's discuss about the greedy algorithm or the greedy approach. So let's consider the coin change problem and we will discuss about the greedy approach or the greedy algorithm. So basically let's consider the coin change problem that aims to minimize. So we'll be considering first, let me write it over here. We'll be considering coin change problem to discuss the greedy algorithm or the greedy approach. So here what we will be doing here, it aims to minimize the number of coins that is needed to make a specific amount by always selecting the largest coin denomination that is available first. So we have to, it aims to minimize the number of coins needed to make specific amount. So to make the specific amount, it aims to minimize the number of coins that is needed by always selecting the largest coin denomination that is available. So by it always selects the largest coin denomination. So I'll just write here largest coin denomination. It always selects the largest coin denomination that is available. So first what we will do, we will sort the coin denomination in the descending order. So we will sort this one, sort the coin denomination. I'll just take it as CD in descending order. So in descending order, just take DSC. So yeah, first we will sort the coin denomination in the descending order and we will iterate through them. We can quickly accumulate the total amount using the fewest coins that is possible. So that's what we'll be doing in this step, second step. And basically, this approach is efficient, right? So let's try to implement this one in the code and let's see this one with the example. I hope the concept will be clear. And also, finally, we'll discuss about the this one, time complexity and the space complexity. So I'll just come here. Just give me a second here. I'll just consider here function coin change. This one will be, I'll just consider coins and amount as parameters. So here our first step is we will sort the coin denomination in the descending order as we had discussed. So here this will be coins.sort. I'll just consider A comma B. Here this will be B minus A, descending order, right? So next step is we will initialize the counter for the number of coins that is being used. Initially, let's consider this one in simple step and just initialize this one to 0 and just take variable name nums of coins and initialize this one to 0. After initialization, as usual, we'll be going through the iteration, nothing but we will iterate through the sorted coin denomination. So we'll be considering the individual coins, right? Iterative. Here for let coin of coins we have considered, right? This one in the parameter. Yeah, I'll just go with the coins, individual coins. Then if no amount is left, then we will exit the loop. We can just make use of the break and exit the loop. So I'll just write this one. This is going to be the base case basically. So if the amount is 0, then let's break out of the loop. The first step is here we will calculate how many coins of the current denomination can be used. Nothing but we will add the number of coins that is used to num coins. So here I can write in this way. So let me write it rather than explaining too much. Here I'll just keep math.flow of amount. This will be by coin. I hope this is clear. After adding the number of coins used to num coins, then we will update the amount that is left after using this coin. So this will be amount module coin. So I can write in this way. So amount equals below this one amount module coin, right? So this one. So nothing but we are updating the amount that is left after using this coin. Final step is we will check if we have reached the exact change. Nothing but we will return the number of coins or we will be returning -1 if no change is possible. If change isn't possible, then we'll be displaying -1. If we have the number of coins, then we will be returning the number of coins. So I'll just come here. Let me come here and let me give return amount. So if it is equal to 0, then we will return num coins, else -1. So I hope this is clear. So this is it. Next, let's check this one with the example. Initially, let's consider the available coin denomination. So I can write in this way. Const coins equals 1, 5, 10, 15. Let me consider. So let me consider this one. Anything, 15, 25, both work. So this has to be not coins, actually const. This is fine. Then let's give the amount that we want to change. In my case, I'll just consider, let me consider 27. So here the amount will be 27. Finally, we will call the coin change function with the coins and amount. So here I'll give const. Let me consider, sorry, this has to be, let me consider this one result. And here let me call the coin change function. And here it consists of the parameters coins and amount, right? Coins and amount. This is fine. Finally, we will output the result. Nothing but minimum number of coins that is needed. So to print, I'll just make use of the console log. And let me write in this way. Let me make use of backticks and the template literals. Here, I'll just give minimum number of coins needed. Here, I can give in this way, right? So here, let me, this one, add the result over here. Yeah. Let me run now. Oh, what happened? Num coins is not defined. This has to be nums of coins I have considered, right? Here, this has to be, just give me a second. Num coins also we have, did I define? Yeah, nums of coins, sorry, here. Just make this one itself num coins. So let me run this one now. So yeah, minimum number of coins that is needed. We are getting this one as 3, right? So just give me a second here. So yeah, we are getting the output 3, right? So the output of the example has to be 3, meaning that we need minimum 3 coins. So here we need minimum 3 coins is needed to make the amount of 27. So minimum 3 coins are required to make the amount of 27 using the denominations that are provided. Nothing but here 1 coin of 25 as per given. 1 coin of 25. For this example, I am writing 1 coin of 25 and 0 coins of 5. You can consider 0 coins of 5 and 2 coins of 1. Finally, we can't consider 10 here, and 0 coins of 5 as well, and 2 coins of this one. 2 coins of 1 we need, right? So here, so 1 coin of 25 and finally 2 coins of 5 we need. Nothing but 3. That is what minimum number of coins needed is 3. So that's what we have got the output, right? So this is absolutely correct. So I hope this is clear how we are making use of the greedy approach over here. So this is it. Next, we will be discussing about the further new algorithms, right? For now, this is it. Thanks for watching, guys.